Okay, I am considering here light is a form of energy which gives the sensation of sight. When light ray incident on the surface, it reflect back. So from the reflecting surface, when the light is incidenting on the surface, it bounces back. Simple definition is the bouncing back of the light from the reflecting surface is called reflection of light. The bouncing back of the light from the reflecting surface is called reflection of light. So when the light is incidenting on the surface, it reflect back. So that is called reflection of light. Reflection of light. So now I'm considering here. So here you can see. So here if you are taking this incident ray, this is the incident ray. Sorry, this is a plane mirror. This is a plane mirror I'm considering. Plane mirror. This is the plane mirror. Okay, so plane mirror I'm considering. Plane mirror. So this is a highly polished smooth surface. Highly polished smooth surface. So highly polished smooth surface is called plane mirror. So when the light is incident on the surface, so this is the incident ray. And I'm considering this a reflected ray. So incident ray, reflected ray. I'm considering this the incident ray, and this is the reflected ray, and the line which is perpendicular to the surface, that is called the line which is perpendicular to the surface, that is called normal line. The line which is perpendicular to the surface, that is called normal line. So now a highly polished smooth surface is called plane. A highly polished smooth surface is called plane mirror. Now I am considering here. So this I am considering this undeviated line. So undeviated line. So the angle between incident ray and normal line is called angle of incidence. Angle between reflected ray and normal line is called angle of reflection. Angle between reflected and deviated line is called angle of deviation. So once again, angle between incident ray and normal line is called angle of incident. Angle between reflected and normal line is called angle of reflection. Angle between undeviated line and reflected ray is called angle of deviation. So here, if you are considering, this is the linear angle. This is the linear angle. So I'm considering 180 degrees will be there. So this is the linear angle, 180 degrees. So that linear angle includes angle of incident plus angle of reflection plus angle of deviation. That linear angle includes here. So I'm considering angle of incidence plus angle of reflection plus angle of deviation equal to 180 degrees. So the linear angle includes angle of incident plus angle of reflection plus angle of deviation. So here angle of incident from loss of reflection. From loss of reflection, if you are taking loss of reflection, angle of incident is equal to angle of reflection. So angle of incident is equal to angle of reflection. First point, incident ray, reflected ray, normal line lies on the same plane. Incident ray, reflected ray, normal line lies on the same plane. Incident ray, reflected ray, normal line lies on the same plane. Incident ray, reflected ray, normal line lies on the same plane. Once again, so this is incident ray, reflected ray, normal line. Incident ray, reflected ray, normal line. And the angle between, so the angle between incident ray and normal line is called angle between incident ray normal line is called angle of incident. Angle between reflected and normal line is called angle of reflection. So from loss of reflection, angle of incident equal to angle of reflection, and incident ray, reflected ray, normal line lies on the plane. Incident ray, reflected ray, normal line lies on the same plane. Here I am considering angle of incident plus angle of reflection plus angle of deviation equal to 180 degrees. I am considering. So here, instead of angle of reflection, I can write angle of incident plus angle of incident plus angle of deviation equal to 180 degrees. So I am considering here angle of deviation equal to 180 180 minus 2 angle of incidence. As I said, so angle of incidence, so I have written, so instead of angle of reflection, I wrote angle of incidence. So instead of angle of incident, I can write angle of reflection also. Angle of reflection also I can write. So now angle of deviation equal to 180 minus 2 angle of reflection. 180 minus 2 angle of reflection. So this is about angle of deviation. This is about angle of deviation. So you can consider angle of incident and angle of reflection. Angle of incident is equal to angle of reflection. Incident ray, reflected ray, normal line lies on the same plane. Incident ray, reflected ray, normal line lies on the same plane. So the bouncing back of the light from the reflecting surface is called reflection of light. The bouncing back of the light from the reflecting surface is called reflection of light. The bouncing back of the light from the reflecting surface is called reflection of light. Is called reflection of light. So here the highly polished smooth surface is called plane mirror. So where the reflection taking place, where the reflection is taking place, that where the reflection is taking place, that mirror is called a reflector. That mirror is called a reflector. Reflector, 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 reflector. Reflector is nothing but the where the reflection of light takes place. Incident ray, the light which is incidenting on the surface is called incident ray. Reflected ray, the light which is reflecting back is called reflected ray. The normal line, the line which is perpendicular to the plane surface is called a normal line. The line which is perpendicular to the plane surface is called normal line. So that is about reflection. And the next one, so we are going to the regular reflection and irregular reflection, regular reflection and irregular reflection, regular reflection and irregular reflection. So here I am considering regular reflection, regular reflection, regular reflection, regular reflection. So I am taking this plane mirror. So this is a plane mirror I am considering. This is a plane mirror. Okay. So when the incident rays parallel, so if the incident rays are parallel to each other, if the incident rays are parallel to each other, then reflector light rays also parallel. Reflector light rays also parallel. This type of reflection is called regular reflection. This type of reflection is called regular reflection. Regular reflection takes place on smooth surface. Regular reflection takes place on smooth surface. Regular reflection takes place on smooth surface. Okay. So this incident beam is parallel. Incident beam is parallel. Incident beam is parallel. Then reflected beam also parallel. Reflected beam also parallel. Reflected beam also parallel. So incident beam is parallel, reflected beam also parallel. So this reflection of light takes place on smooth surface. So regular reflection takes place on still water and a highly polished surface, that is a plane mirror I am considering. Next one, irregular reflection. So I am considering irregular reflection. Irregular reflection takes place on rough surface. You are considering this is the irregular reflection. So irregular reflection, irregular reflection, irregular reflection. So I am considering incident beam. But reflected beam is not parallel. Incident beam is parallel, but reflected beam is not parallel. So it goes in different directions. Like this. So here, inside whatever you are taking, that is a smooth surface. Smooth surface. This irregular surface, rough surface. Rough surface I am considering. Rough surface. Rough surface. Rough surface. Okay, irregular reflection. Incident beam is parallel, but reflected beam is not parallel. Incident beam is parallel, but reflected beam is not parallel. This type of reflection is called irregular reflection. This type of reflection is called irregular reflection. So here incident beam is parallel, but here reflected beam also parallel. Incident beam is parallel, reflected beam is also parallel. This type of reflection is called regular reflection. So whereas rough surface, incident beam is parallel, but reflected beam is not parallel. So this type of reflection is called irregular reflection. So regular reflection takes place on smooth surface and plane mirror, and also it takes place on still water also we can say. Rough surface, so regular reflection takes, this is a regular reflection takes place on a plane mirror and still water, okay, and irregular reflection takes place on wall, on paper, on book, like that. Any rough surface I'm considering. So because of irregular surface, okay. Next one, we are going to the next topic is image, real image and virtual image, real object and virtual object. I will explain, so listen carefully. So I'm considering now real object and virtual object, real image and virtual image. So I'm considering here, this is a plane mirror. I'm taking like this. This is a plane mirror. So plane mirror. So here I am taking the object is here. Object I am placing. So this is the object. If you are taking object here, so how many light rays are required to form the image of the object? Minimum 2 light rays. Minimum 2 light rays. Minimum 2 light rays. 2 light rays. Minimum 2 light rays are required to form the image of the object. So I am considering from here, one light ray I am taking like this, another light ray I am taking like this. So it will be reflected back. Okay. So incident ray, this is I1, R1, I2, R2, R2. So if you are extending these light rays, so you can observe, if you are extending these light rays, those light rays will meet at one point. Their image will, this is a real object. This is a virtual image. So here you can see the point of intersection of incident rays is called real object. The point of intersection of incident rays is called a real object. So here we can see the point. This is a reflected ray. So we are extending this reflected light rays. Those light rays are at one point. So their image is forming. That is a virtual image. And one more I am taking here. So if you are considering this is a plane mirror. Okay, so light rays are coming from infinity. If the light rays are coming from infinity, after reflection, light rays will meet at one point on the principal axis. So after reflection, light rays will meet at one point on the principal axis. So here image will form. So if you are extending this incident rays, so these are the incident rays. If you are extending this incident rays, those incident rays will meet at one point. So here is a real image. This is the real image. So this is the virtual object. This is a real image and virtual object. So how can you identify this real image and virtual object? So here now I will tell one simple logic to remember these points. So simple logic. So how many light rays are required to form the image of the object is minimum 2 light rays. So how many light rays are required to form the image of the object? Minimum 2 light rays are required. So now I am considering here. So object and image. So if the object is real, image is virtual. If object is real, image is virtual. The point of intersection of incident rays is called real object. The point of intersection of extended reflected light rays. So this is one reflected ray. Those reflected light rays are extending and meeting at one point. So their image is forming. That is a virtual image. So here is a virtual image. The point of intersection of reflected light rays is called virtual image. The point of intersection of reflected light rays is called virtual image. image. The point of intersection of reflector light rays is called virtual image. The point of intersection of reflector light rays is called virtual image. The point of intersection of incident rays is called real object. The point of intersection of real object incident rays. The point of intersection of incident rays is called real object. The point of intersection of extended reflector light rays. The point of intersection of extended reflector light rays is called virtual image. So here you can see the point of intersection of reflector light rays. So these two are the reflector light rays. Those reflector light rays are meeting at one point. Those reflector light rays are meeting at one point. The point of intersection of reflector light rays is called real image. The point of intersection of reflector light rays is called real image. Here the point of intersection of extended incident rays. So this is the incident ray. This incident ray I1 and reflector ray R1, incident ray to I2, reflector ray R2. So we are extending this incident rays. Those incident rays are meeting at one point. So their virtual object is formed. So here real object and here is the virtual object. Sir, what is the difference? So this is a real object, their virtual object. How it will form? So here the point of intersection of incident rays. Incident rays are coming from that point, that is called real object. So here the point of intersection of extended incident rays is called virtual object. So object is real, image is virtual. Object is virtual, image is real. Object is virtual, image is real. So these are the points. So these are the points you can observe. Very important point. So here you can conclude that object is real, image is virtual. Object is virtual, image is real. Object is virtual, is real. So these are very important points. So make sure that you are practicing all these points, because for exam point of view, so they will ask this question: where image will form, where object is formed, what is the image, what is the object, what is the real image, what is the virtual object. So here I will tell from this point, from this diagram, we can take 4 points. Point number 1, object types. Object two types. Object two types. What are those? First one, A is real object, and second one is virtual object. Coming to the image, second one is image. So image two types. One is a real image, and second one is virtual image. So what is the difference between real and virtual, real object and virtual object, real image and virtual image? Means, so here you can see this is the real object. So this is the virtual object. A real object and virtual object. Virtual image and real image. So if the incident rays, so here incident rays directly meeting, so that point is called real object. So incident rays, extended incident rays meeting, that is called virtual object. So reflector light rays, extended reflector light rays are meeting at one point, that is called virtual image. Extended incident rays, extended reflector light rays. So this is one reflector light ray, this is one reflector light ray. So this extended reflector light rays are meeting at one point, that is called virtual image. So here you can see reflector light rays are meeting directly. So that's why it is called real image. This is called real image. So that is about object types: real object, virtual object, real image and virtual image. So very important point. So make sure that definition point of view, they will ask 1 mark, 2 mark in the board exam, they will ask this question. So make sure that you are learning this point. So coming to the next one. So if you are going to the next one, virtual nature of the image formed by the plane mirror. So what is the nature of the image formed by the plane mirror? We will discuss now. So if you are considering here, so if object is real, so I am considering now. So I am taking here this plane mirror. So I am taking the plane mirror here. So plane mirror now, considering the plane mirror like this. So here I am considering the object. This is the object. Object is height. Height of the object is AB. And how many light rays are required to form the image of the object? Minimum 2 light rays are required. So I am considering 2. So here you can see. So one light ray I am taking like this, so it passes like that. So it passes it. Sorry, that is normal line. Normal line. Normal line. So I will tell one example related to this one. So if the light ray is passing along the normal line, if the light ray is passing along the normal line, it reflect back into the same path. It reflect back into the same path. Retrace its original path. Retrace its original path. Same thing here also. If the light ray is passing along the normal line, it reflect back. And one more light ray I am considering here. So it reflect back like this. And here also I am considering. So this one, okay. So if you are extending this reflector light rays, so I'm extending here. So you can observe. So here these are the extended reflector light rays. This is the extended reflector light rays, and here also extended reflector light rays. So here extended reflector light rays. So here image will form. Here image will form. So here what type of image will form? What type of image will form? So let me know. So image will form virtual and erect. So here A, B, A dash and dash. So A, B, A dash and B dash. Okay. So now we can take and here the distance between object to mirror is called object distance. The distance between object to mirror is called object distance. The distance between mirror to image is called image distance. The distance between object to mirror is called object distance. The distance between mirror to image. So this is the mirror. So I am considering this is the plane mirror. Plane mirror. This is the plane mirror. The distance between, okay, so object to mirror is called object distance. The distance between mirror to image is called image distance. So this is about the plane mirror. Now you are considering here. So now you can see. So what are the points? First point, if you are coming to the first point is, okay, so object is real, image is virtual. Object is virtual, image is real. So vice versa I am considering. If object is real, image is virtual. If image is real, object is virtual. Like that we have to consider. So vice versa I am considering. Next one, object distance is equal to image distance. Object distance is equal to image distance. And the second one, height of the object is equal to height of the image. So this is the object height and this is the image height. Okay, so object height and image height. Height of the object is equal to height of the image. Height of the object is equal to height of the image. So object distance is equal to image distance. Height of the object is equal to height of the image. Object distance is equal to image distance. Height of the object is equal to height of the image. Height of the object is equal to height of the image. So very important points. And the next one, third one. So it also shows the lateral inversion. So it also shows the lateral inversion. Okay, lateral inversion. So plane mirror where we can use looking glass and in staircases, double decker bar, like normally we can see in staircases also we can use. So periscope also we can use this plane mirror, and for looking glass also. Lateral inversion. So what is the lateral inversion? Lateral inversion is nothing but the phenomena of appearing of right side of the object appears to be left side of the image, left side of the object appears to be right side of the image. So right side of the object appears to be left side of the image, left side of the object appears to be right side of the image. So this mirror reflection is called this type of mirror reflection is called lateral inversion. This type of mirror reflection is called lateral inversion. The phenomena of converting of left side of the object appears to be right side of the object appears to be left side. So this mirror image is called lateral inversion. Best example, you can see the letters written on the ambulance. See, the letters will be written in the reverse format. So reverse format in the sense mirror reflection. When you see in the rear view mirror, so side view mirrors, side buses, cars, and even bicycle. Okay, so if you're seeing that one, bikes, so bike, scooty. Okay, side view of that one. So in the rear view mirror, we can able to see the ambulance letters will be clear. Okay, so that about lateral inversion. So these are the 3 points. Object distance is equal to image distance. Height of the object is equal to height of the image, and also lateral. It also shows the lateral inversion. So this is about plane mirror. Nature of the image formed by the plane mirror. Nature of the image formed by the plane mirror. Right. So next one we'll go to the spherical mirrors. Spherical mirrors. Spherical mirrors. Okay. So if you are taking the curved mirror, so I am taking the sphere. So I'm taking the sphere like this. Okay, so it is a part of this sphere. So we are taking sphere. If you take a small portion, if you are taking small portion, that is called curvature. That is called curvature. Based on the reflection part, based on the reflection. So if the light reflection takes place inside of the mirror, that is called concave mirror. If the reflection of light, if the reflection of light takes place inward, if reflection of light takes place inward, that is called a concave mirror. Reflection takes place inward, that is called concave mirror. Concave mirror. Concave mirror. So reflection takes place outward. So pole, focus, center of curvature. Pole, focus, center of curvature. So if the reflection takes place outward, so I'm considering like this. Okay, reflection takes place outward, that is called a convex mirror. Reflection takes place inward, that is called concave mirror. Reflection takes place outward of the mirror, that is called convex mirror. Reflection takes place inward, that is called concave mirror. Reflection takes place outward is called convex mirror. Convex mirror. Convex mirror. Convex mirror. Okay, so concave mirror and convex mirror. Concave mirror is also called converging mirror. Concave mirror. Concave mirror is also called converging mirror. Converging mirror. Converging mirror. And a convex mirror is also known as diverging mirror. So diverging mirror. This is called diverging mirror. Diverging mirror. So here are diverging. So why it is called converging? Why it is called diverging? Converging means whenever the light ray falls on it, whenever the light rays falls on it, immediately, so the light rays are converging towards its principal axis, So you can see the light rays are converging. So after incidenting, it will be converging. So whereas here, so after reflecting, so the light rays are diverging. The light rays are diverging. So that's why it is called converging and diverging mirror. Okay. So next one we'll go to the ray rules of the concave mirror and convex mirror. Ray rules of concave mirror and convex mirror will discuss. Ray rules. Okay, we'll see ray rules. Now I am talking about, we will explain about ray rules. Ray rules, if you are considering, so concave mirror, I'm talking about concave mirror. Concave mirror is concave mirror. So here, okay, before that, we will discuss about the terms related to spherical mirror. Then I'll go to the concave mirror ray rules. Terms related. Terms related to spherical mirror. So here I'm considering. So it is a part of the sphere. This is the part of the sphere. This is the part of the sphere. Okay. So this is the part of the sphere I am taking. Part of the sphere. So here it is the center. This is the center. And the midpoint of the mirror is called, this is the midpoint of the mirror. So here is the midpoint. So this is called pole. The midpoint of the mirror is called pole. The midpoint of the mirror is called pole. The center of the imaginary sphere. So first one is pole. Second one is center of curvature. So the midpoint of the mirror. So midpoint of the mirror is called pole. And center point, center of the imaginary sphere in which mirror is a part. Center of the imaginary sphere. So here you can see. So here I am considering this is this total, it is a mirror. So this the total is a mirror. Okay, so this is the mirror I am considering. This midpoint of the mirror is called pole. So this is the center of the imaginary sphere, center of the imaginary sphere in which mirror is a part. So this is a part of, this is the mirror. Okay, so this mirror is a part of the sphere. This mirror is a part of the this sphere, entire sphere. So we are taking only this curvature. We are taking only this curvature. So this is the center of the curvature. The line joining of center of curvature and pole is called, the line joining of center of curvature and pole is called principal axis. Principal axis. So third one is principal axis. Principal axis. Principal axis. And fourth one, coming to the fourth one, the distance between center of curvature to pole. The distance between center of curvature to pole is called radius of curvature. The distance between center of curvature to pole is called radius of curvature. And fifth one is, so after reflection all light rays will meet at one point. After reflection all light rays will meet at one point on the principal axis, that is called focus. So here you can see, this is called focus. After reflection all light rays will meet at one point on the principal axis, that is called focus. So focus, capital F. And the sixth one, the distance between focus to pole is called focal length. So the distance between focus to pole, the distance between focus to pole is called focal length. So denote with a small letter. So the distance between focus to pole is called focal length. So denote with a small letter F. And seventh one, if you are taking the width of the mirror, where reflecting surface, where the light rays are reflecting, that is called this width of the mirror or diameter of the mirror is called, reflecting surface is called aperture. So that is about so pole, center of curvature, principal axis, radius of curvature. The distance between center of curvature to pole is called radius of curvature. The distance between, see, after reflection all light rays will meet at one point on the principal axis, that is called principal focus. Simply we can focus. The distance between focus to pole is called, the distance between focus to pole is called focal length. The distance between focus to pole is called focal length. The distance between focus to pole is called focal length. So width of the mirror is called aperture. 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 So the distance, so here once again, pole, center of curvature, principal axis, radius of curvature, focus, focal length and aperture. So these are the 7 parts. Terms related to spherical mirror. Terms related to spherical mirror are terms related to spherical mirror. Okay, so next one. So I'll explain about ray rules now. I'll explain about ray rules. Just go through it. Ray rules. Ray rules I'm explaining. So ray rules. Ray rules, ray rules, ray rules, Ray rules. So ray rules of image, ray rules of concave mirror. 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 First one is, so first one I'm considering this one. So pole, focus, center of curvature. Pole, focus, center of curvature. So one light ray I'm taking like this. After reflection it passes through focus. Second one I'm taking. Second one. So pole, focus, center of curvature. Pole, focus and center of curvature. If the light ray passing through focus, if the light ray is passing through focus, after reflection it passes towards infinity. And coming to the third one, third one I'm considering this is the third one. So this is the pole, focus, center of curvature, pole, focus and center of curvature. So if the light ray passing through center of curvature, if the light ray is passing through center of curvature, it retraces its original path. Coming to the fourth image formation, fourth one, if the light ray is passing like this, so here is the pole, focus, center of curvature. If the light incident at the pole, it reflect back. Okay, so these are the ray rules of concave mirror. Coming to the ray rules of convex mirror. Convex mirror, if you are considering convex mirror, ray rules of convex mirror. So here I am taking convex mirror. Ray rules of convex mirror. So point is, so I am taking like this. Sorry, convex mirror. Right? Convex mirror is different. This is a convex mirror. So here I am taking this the pole, focus, center of curvature, pole, focus, center of curvature. So I am taking one light ray. Light ray is coming from infinity. After reflection it passes, it will passes like this, passes through focus. Second one, so I'm considering the convex mirror. So here is the pole, focus, center of curvature. So if it is passing through focus, after reflection it passes through focus. Second one, third one is convex mirror. If the light ray is passing through center of curvature, so here is the center of curvature. If the light ray passing through center of curvature like this, so it reflect back, retrace its path. So it's same path. So it retrace its path. It reflect back into the same path. And coming to the fourth one. See once again. So here I'm considering like this. So last convex mirror image formations. So this is the pole, focus, and the center of curvature. If the light ray incident at the pole, it reflect back. Okay. So now I will explain about all these ray rules. So here you can observe. So I am taking here light ray is coming from infinity. After reflection passes through focus. So if the light ray passing through the focus after reflection moves towards infinity. So if the light ray passing through center of curvature, it retraces its original path, reflect back into the same path. And here you can consider if the light ray incident at the pole, it reflect back into the same medium. So these are the ray rules of convex mirror. Next one I will explain about ray rules of image formations of concave mirror. Image formations of concave mirror. I will explain. Just listen. Image formations of concave mirror. First, we will discuss about concave mirror. Next one, I will explain about convex mirror. So this is about concave mirror. Now I will explain. Just listen. So concave mirror. So we have to discuss about concave mirror. So now I am considering here. So first one, concave mirror. Image formation. So these are the not ray rules. Image formations we are discussing. Image formations of concave mirror. Image formations of concave mirror. Image formation by concave mirror. Image formations by concave mirror. So now I am considering when object is at infinity. First one, if the object is at infinity, so I am taking like this here. So pole, focus, center of curvature, pole, focus and center of curvature. Object is at infinity. So how many light rays are required to form the image of the object? Minimum 2 light rays. Are required. So that's why so here object is at infinity. So how many light rays? I am taking one light ray. So it will reflect back. And another one I am taking here. So here you can see. So focus. This light ray will incident here. Object at infinity, image will form at focus. So nature of the image is real and inverted. Nature in this case, so real inverted image and highly diminished image will form. Highly diminished image. Real inverted and highly diminished. Real inverted and highly diminished. And coming to the second case. So here I am considering like this. So this is the pole, focus, center of curvature, pole, focus and center of curvature. So if the object is placed beyond center of curvature, like this I am placed. Object is placed beyond center of curvature. So one light ray I am taking like this. So it passes through focus. Another light ray passing through center of curvature. So the image will form between C and F. Object is placed beyond C. So image will form between C and F. Nature of the image is real inverted and size of the image is diminished. Compared to the object, image size is decreased. Compared to the object, see once again. So in this case, object is at infinity, image is formed at focus. So nature of the image is real inverted and size of the image is highly diminished because here it is formed point size image. So here you can take object is placed beyond center of curvature. So how many light rays are required? So minimum 2 light rays are required. So that's why I am taking 2 light rays. So one light ray is passing like this, another light ray is passing. So those light rays are meeting between C and F. So object is beyond C, image is formed between C and F. So nature of the image is real inverted and size of the image is diminished. Very, very important point. Size of the image is diminished. And the next one, third one is very, very important. So if you are taking here, in this, based on this one question will come. One question will come in the exam. So here I am considering the pole. So focus and center of curvature. So pole, focus, center of curvature. So object is placed at C. So how many light rays are required? Minimum 2 light rays are required, I said. How many light rays are required? Minimum 2 light rays. So I'm considering one light ray, I'm taking like this. So it passes through focus. It passes through focus. And the second light ray I'm taking like this. So after that, it reflect back. So the image will form here. The image will form here. Okay, so I'm considering here. Object is placed at C. Object is placed at C. Image also will form at C. Object is placed at C. Image also will form at C. Nature of the image is real inverted, and size of the image is same size. 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 So how can you identify? So here, if the object is placed at C, image also will form at C. So nature of the image is real inverted, and size of the image is same size. Same size image will form. Same size image will form at center of curvature. So the minimum distance between real image and real object, object and its real image in concave mirror is 0, because object is placed at C, image also will form at C. So the minimum distance is 0. The minimum distance is 0. Next one, we are going to the next one. So fourth one. So I'll explain about fourth one. You can see. So fourth one, fourth image formation. So we'll discuss about fourth image formation. Object is placed between C and F. Object is placed between C and F. One light I am taking like this. It reflect back. Another light I am taking at pole. So it reflect back like this. So those light rays will meet so here like this. Okay, so object is placed between C and F. C and F. Image will form beyond C. Beyond C. Nature of the image is real inverted, and size of the image is enlarged image. So enlarged image will form. Enlarged image will form. Enlarged. So enlarged image is formed. So next one, fifth one. Fifth one you can see. So object is placed at F. So how many light rays are required? Minimum 2 light rays. So I am taking one light ray here. So it passes through focus. Object is at F. Image will form at infinity. So object is at F. Image is formed at infinity. So nature of the image is real and inverted, and the size of the image is highly enlarged, because image will form at infinity. Image will form at infinity. And coming to the sixth one. So if you are considering object is here P, F, C. Okay. So object is a very important. So very important point. So if object is placed in F and P, one light I am taking like this, passes through focus. Another light ray is incident at the pole, reflect back. The image will form behind the mirror. So image will form here. Image will form here. Object between F and P. Object is placed between F and P. Image will form behind the mirror. Image will be behind the mirror. Behind the mirror. Nature of the image is virtual erect and enlarged. Virtual erect and enlarged. virtual, erect and enlarged. So once practice this one, so I hope it is clear. So next one, do you have any doubts on this? Okay, so we'll see in the next class. So thank you so much for attending and listening the class with so much patience. So this is your Siva sir. This is your Siva sir. So I started CBSE Grade 10 Physics course. CBSE Physics Grade 10. Light reflection and diffraction, human and color fluid, electricity and magnetic effects of electric current. So these 4 chapters explanation and soft copy notes, 100 definitions from these 4 chapters, 100 problems from electricity chapter. So this all I am providing with the cost of 500 rupees. Those who are interested, you can take the course. So you can contact to this number. So this is my number. So you can contact to this number. On this WhatsApp is there. So reach to me on this number. So if you like this content, do like, share and subscribe to Student in the Brand. This is your Siva sir signing off. Thank you.